All right. Hello, everyone. Thank you for watching today's presentation, which is Safety Without Borders, Protecting Plants in the Era of Remote and Mobile Work. My name is David Nolan. I'm an Industry Solutions Manager here at SmartSites, and I'll be the presenter today. All right, let's go ahead and get started. So today, our agenda is sort of an overview of the existing in-plant alarm systems in 2025 with all of the high-tech mobile applications that we have. Could these systems potentially be holding us back? Um, and that'll take us into sort of defining some of the terms for the conversation around optimizing the alarm life cycle as a way to proactively monitor and increase safety. Um, then we'll get to the how and why of optimizing that cycle at the condition level, as an operator responds to a specific alarm condition. Then we'll talk about optimization at the plant and enterprise levels. As far as questions, unfortunately, this is a recorded presentation today, so any questions that you might have, you'll have to submit to us by email, but we are happy to answer those. All right, so the in-plant alarm system, is it an asset? Is it a liability? Is it a bottleneck? I think with the way that they tend to be implemented in most places, it's obviously a bit of all three, rather unfortunately. Um, just to kind of talk about existing in-plant alarm systems, such as what you would find with a typical SCADA HMI or DCS system. They're effective for control rooms or perhaps for distributed HMI displays out on a production floor, production area. But obviously, these systems typically require human intervention to call for remote assistance. The alarm is going to display on the HMI. It's going to maybe enunciate over a siren or a speaker or something. Um, but it's not going to call a mechanic on the phone to go and fix a problem, for example. Um, Many control systems at the plant level have thousands or tens of thousands of different conditions. And so when an operator interfaces with them, say through an HMI, they can experience things like floods, chattering alarms that are flickering in and out very quickly, stale, ignored alarms that the guy on the last shift just lets sit there for 8 hours, mass suppression of the system. So maybe there's alarms that they're not even seeing. So it can be difficult for an operator to actually interact, with a specific critical alarm that's relevant to their role or their work area or their production line, uh, et cetera. So there can be a lot of sort of aggravating aspects to dealing with uh, in-plant alarm systems as they tend to be implemented across many different plants and industries. Um, and this sort of leads to the question, do we really need a human being staring at a screen to monitor alarms? And I think for a lot of applications, the answer to that question is probably yes. But if anyone in the audience is even remotely aware of what we do here at SmartSites, we're going to give the answer to that question as a resounding no, as in that there are other ways that we can use to enhance our monitoring of safety in the plant through the alarm system. So um, how do we go about uh, implementing some of these more advanced remote systems to enable autonomy and really effective remote monitoring? That's sort of the basis of the discussion here. Before we can do that, we'll just lay a little bit of groundwork in terms of the terminology that we'll be using around alarms and alarm life cycles. So um, what is an alarm? I think we've worked in plants. We have all experienced alarms and know what they are. But basically, an alarm is an abnormal condition in a process that requires a response from an operator or other stakeholder or other role. So if it's a prompt that requires a response, but it's a normal process condition, that is not an alarm. If it's an abnormal condition that does not require a response, that's also not an alarm. So it's really the intersection of those two concepts of abnormal and requiring a response. Now, the alarm life cycle, we say life cycle, we really mean the process of when an alarm is generated by an abnormal condition, and from that time to when the condition returns to normal. So there are several states that can happen there. So typically the first state is active and unacknowledged. That's a new alarm, which means the abnormal condition has occurred. No one has yet responded to it. Excuse me. Active acknowledged means, okay, someone has responded to the active alarm. That way other people in the plant, other users of the HMI SCADA system understand that they don't have to respond to that alarm because someone else has. Inactive unacknowledged means that the condition has returned to normal before anyone has acknowledged it. Um, Now, if that's actually true and the condition has cleared on its own, right, that indicates maybe it's not actually an alarm as per the ISA definition we just talked about, or perhaps the operator just never acknowledged it in the HMI system, though they did, you know, physically in the real world, you know, acknowledge it and respond to it. And that can happen for a variety of reasons, you know, due to a poor interface or the alarm occurring in the middle of a flood and them not understanding, you know, how to find it and acknowledge it on the screen. There's all kinds of logistical reasons why, you know, the alarm could end up in this state. Regardless, the terminal state of the alarm lifecycle is inactive and unacknowledged. We've returned to normal and someone has acknowledged that the problem happened. So we'll be using these terms, you know, throughout the discussion. So just basically take note of this, you know, this 2D matrix concept of activation and acknowledgement. Though obviously many in the audience here obviously are probably very, very familiar with these terms. So why should we expedite this cycle? Again, this may be obvious to many in the audience, but basically reducing the occurrence and duration of alarms, it increases operator focus and attentiveness, right? If people aren't constantly trying to parse through what is happening that's abnormal, responding to abnormal conditions, right? They can focus more on doing their job rather than responding from crisis to crisis all the time. So this reduces downtime, obviously increases efficiency and safety, and then increasing alarm visibility via remote monitoring specifically can also allow people to reduce labor costs, right, by eliminating overnight shifts. Picture something like a water plant, for example, where many times by law, right, these plants are required to be monitored 24/7, 365, either by a person physically being in the plant, or it is also acceptable, you know, in most regions, states, and localities to do this monitoring by remote software, for example, such as smart sites. All right, optimizing the alarm life cycle. Uh, so when we think about optimizing the alarm life cycle, we can think about it again from sort of two phases, right? The time to acknowledgement and then the time to inactivation. So that sort of first half of the battle, if you will, is the acknowledgement time. The time between the alarm occurs when someone responds. Smart Sites offers a solution that can drastically reduce this time. And it works by monitoring the in-plant alarm system, right? The HMI, SCADA, or other type of control system managing the alarms inside of a plant. And then it has an intelligent, autonomous engine that can route that alarm to the right person at the right time via the right method to reach them, regardless of what the problem is, who they are, or when this problem is occurring. And the system works by integrating with, you know, workers' schedules. When an alarm occurs, it knows who is actually on call and, you know, who is out of bounds and who it shouldn't reach out to. It supports escalation, right? It can give a time window for operators to answer, and then it can escalate the issue to engineers, and then, for example, to a plant manager if no one in that chain acknowledges the alarm within the time window. Uh, You could escalate by method as well, right? So notify by a text message or an app push notification or some more passive method. And if that method doesn't get a response, start a phone call, which is a little bit harder to ignore, for example. Um, the system can also use branching logic, right? So for high severity alarms at night, notify all contacts, otherwise notify the appropriate operator of the process area where the alarm is occurring. Um, and one, perhaps the most important part of a remote system, right, that reduces acknowledgement time is the acknowledgement in the remote system has to sync with the implant SCADA or other alarm systems, so which SmartSight's solution does. So when an operator acknowledges an alarm by tapping the act button on our mobile app, responding to the text message or email, or speaking into their phone on the phone call, that does sync into the implant system. And people on the HMI, for example, can actually see that the alarm was acknowledged by David Nolan via Win 911 by a voice call. And here in the diagram on the right on the slide, we can just see an example of what this looks like on our iPhone mobile app. So you can see here in the notification tray, now we do have some notifications from the SmartSights app, so we get those ringing our phone or giving us a vibrate. We open that up, we see a live feed of any and all alarms that are going on that we're subscribed to in the plant. We can open the one up that we want to interact with. We can see a history of the alarm. For example, this is the first time this alarm has happened on this given day. It's currently in the active unacknowledged state. We can tap the button to acknowledge it. We can put a comment in, and that comment will then go back into the implant HMI SCADA system, and we'll see the status reflected here in the app as well. Now, you get some other things here that do help in terms of speeding up acknowledgement time and enforcing accountability. We do get a user audit here, so you can see, for example, in this alarm, the notification was sent to Christian Kelly. He did not acknowledge in the allotted time. It was then escalated to me. If I had not acknowledged it, it would then be escalated to Torsten, for example. You also get a persistent group chat here. So this ties more into the activation time side of things, right? So if we look at everything up to when we hit that act button, right, as trying to speed up that acting process, now we're in reducing the activation time. How do we actually resolve the condition? And so in terms of the chat feature, this allows you to interact with the people who are in that response group for that alarm and that call out list. It also allows people to flag known resolutions to these conditions, right? So if there's an older, more experienced operator or engineer in the group, they can, give tips to the other guys and say, hey, when this alarm happens, it's typically because this, this sensor on this machine is, come knocked loose or something. Just whack the machine on the side and it should start up going again. That might seem kind of silly, but people who have actually worked in industrial facilities will know that their equipment doesn't work perfectly out in the real world, and there's a lot of tribal knowledge out there in terms of how problems get fixed. And so features like this do allow that knowledge to be shared and kind of more institutionalized. Again, because within this chat feature, it is persistent. So if there is a known solution, the next time the alarm happens, that will be resurfaced again on this chat tab right away. On the other side of things, we talked about sort of the collaborative aspect of reducing activation time. There's also a diagnostic component. Can we use information and visuals powered by data in the SCADA system, the history, to sort of enhance our contextual understanding of the alarm, or monitor it as we're resolving it, and our actions actually bringing the process back into normal operating conditions. So SmartSights does also support this functionality in our mobile app. So for example, if we wanted to go look at what was happening with some of the equipment tied to those pump systems we were seeing the alarms for, we can do that by drilling into the reporting feature of the mobile app and say we want to look at, for example, a trend here. We can identify maybe beyond just the alarm state tag on those pumps, we can actually take a look at the flow that's going through them, leading up to or during the time of this alarm response. So we can browse tags, directly from the SCADA system. We can identify the time frame of the alarm, or of the time period of interest we want to frame up inside of this visual, and then we can generate it. We can see here, for example, what was going on with maybe an adjacent asset or an adjacent KPI. It's very easy to change the time frame or change out the tag, right, that we're framing up in here. So it's a very quick and easy to use tool. Lets you harness all the kind of information you'd normally have to be in front of an HMI or logged into an HMI, or another sort of vision tool to see. This sort of allows you to frame it very easily and quickly, directly in the context of the alarm and the tags and the data, all related to that event that you're responding to at the time. And this trend is just one example of a diagnostic visual you might put inside this app. There's dozens of different layouts that can be used, or completely configurable layouts can be created using any tag available in a SCADA system, or any time series data source available in the plant, using all kinds of different calculations and visual tools as well. So we talked about reducing the acknowledgement time, reducing the activation time. Now we'll talk about standardizing resolutions and maybe more root cause analysis and alarm prevention, right? So I think the ultimate goal of optimizing the alarm system is probably to have fewer alarms in the first place, right? So SmartSites has a component, an issue management component, that helps tackle sort of this piece of the puzzle. So it goes beyond just raising an alarm notification from the SCADA system to an operator, to more escalated and operator-initiated calls for help. So this basically kicks off more of a structured follow-up action that occurs either as the result of an alarm. This can be initiated automatically when an alarm occurs, or it can be initiated by an operator, right? If there's a safety issue, like a spill on the floor, for example, that's typically not going to be reflected as an automated alarm in the SCADA system, but an operator can report it. So think about this in the context of allowing operator-initiated alerts to follow that same sort of structured format as a SmartSites remote alarm response. And think about it also as allowing different types of people and departments, right, to get involved in this process. This is really more geared around looking at a plant manager, for example, looking at all the different issues of all different kinds that might be going on inside their facility or their network of facilities. From the operator's standpoint, and from maybe a supervisor's standpoint, it does allow specific follow-up actions to be taken, observations, measurements, photos to be taken, with the goal of understanding root cause, and improving and standardizing the response to alarms. And this can also be used as part of, for example, an alarm rationalization effort, is what the operator's doing and documenting, matching up with how this alarm is described and documented from the control system side. So how this actually works is either, again, automatically or initiated by the operator. We can create a ticket. Let's say we want to create a quality ticket, for example, inside of like a food and beverage plant. So we'll say that we're in the packaging area of the plant. It's the line 1 case packer asset. This is happening while we're doing this particular product run, and we need the materials team to go and investigate this, right? So we fill out all this information. We can document what the problem is. Maybe the materials are out of materials, or the materials are jammed inside the machine or something, and it's happening on this particular asset. So we can notify the materials group. The plant manager can also see a big screen view of all this, with all the different issues that might be going on inside the plant. And if this is tied to an alarm, by the way, closing out the alarm will close the ticket. Closing the ticket will close the alarm as well. So it's a closed loop process if this is being integrated with, say, a Win 911 alarm. The idea here is that we're basically, excuse me, doing a couple things. We're allowing the operator to quickly call for help. We're also injecting, specific follow-up actions within this process to better understand the problems. We're going beyond just the specific alarm life cycle of acknowledgement and activation into more, what were the problem-solving steps, right, that we took to fix this. We can see here that, we have much more detailed state tracking, again, than just the alarm life cycle. We can see a timeline of what was done, and we can use that then, say, to standardize the response to the alarm in the future. Okay, so we just spend a whole lot of time talking about responding to alarms at the condition level, again, thinking back to the presentation agenda. Now let's change gears a bit and talk about understanding alarms at the system level, at the plant or the enterprise level. So in this part of the discussion, we're going to talk about alarm rationalization. And this diagram you see over here is not a SmartSites diagram. This is an ISA 18.2 diagram that basically outlines the framework for alarm rationalization, which is basically the process of implementing, operating and managing alarm systems inside of a plant. So there's an initial, philosophical discussion around, what are we doing in this plant, and why do we need alarms, right, to protect the product or keep people safe? What are the conditions we're really talking about there? Identifying those, designing the alarm system, what's going to trigger the alarm, how is it going to be enunciated so people can respond to it, that kind of thing. Once all that's laid out for the plant, it can be operated. Operators actually will run the water plant or the bottling plant or whatever we're talking about, and we'll actually be able to monitor how this system is working. Our operators responding to alarms in a timely manner. Are we getting an excessive amount of downtime or product quality issues? That will inform basically our management of change, right? The operators are getting flooded with all kinds of alarms. We need to go and change some of these conditions here because this, really isn't working. And the problem is you have, again, in many plants, right, you have thousands and thousands of alarm conditions. So it's not like you can simply pour over every one of those and reevaluate it all the time on a continuous basis. So it requires statistical analysis, right, to do this monitoring and assessment piece. What are the most commonly occurring alarms? Why are they occurring? Are they shattering alarms? That kind of thing. Are you getting alarm floods? And focusing on the conditions, right, that are part of those, sort of problem metrics, and then prioritizing those, say, in the management of change. So we do this basically on a continuous basis to improve, the performance of the alarm system, to improve safety, to improve uptime, to improve quality, and so on. And we do this, not only for those reasons, but because, this process is also, understood and accepted by organizations like OSHA, the insurance industry, and so it can affect things, for example, like insurance rates. All right, so that is alarm rationalization and why we're doing it. And so when we think about, what we sort of talked about so far, right, the things with managing activation time and acknowledgement time sort of fit in these, areas here. Now we'll sort of look at this area here. How can we sort of help with the monitoring and assessment component of this cycle, right? So that's where these system level reports kind of come in. And these work just by pointing at the historical database associated with an in-plant alarm system from systems like Rockwell Automation's FactoryTalk or Aviva System Platform, Emerson's Delta V system. alarm systems like that. This tool will point either at the history of those systems or at the history of a Win 911 system, and analyze some of the data coming out of it. And um, this presentation won't be an in-depth discussion of every aspect of the data in these reports, but some things to think about, for example, are, if I'm going to re-rationalize my system and tune it up, and I want to focus on, just one specific metric on this report, it'd probably be top 10 contribution, right? I've got 5,000 alarm conditions in my plant, and the top 10 are taking up like 64% of all the activity. Well, those are the ones I really want to take a very, very close look at to see if they're actually, programmed effectively. Right, so this tool allows you to do that, to drill down behind this number and see, for example, a Pareto analysis of what's making up that top 10. Even within the top 10, there's really one specific condition that's happening a little more than once a minute, right? So it's a constantly chattering alarm. Um, you know, Clearly this is something that's always up on the HMI. It's probably distracting, bothering, irritating operators. Can lead to fatigue or desensitization to alarms. So what we probably really would want to do here is re-examine, what are we actually doing with this alarm? Do we even need this thing at all? Can we put an activation delay on this thing to help with the chattering, et cetera? So you run these reports, periodically, weekly, monthly, quarterly, and just continuously address your bad actors till the distribution curve sort of starts to smooth out, and you eliminate a lot of the chattering and allow the operators to sort of focus on, doing their jobs, for example. So we kind of looked at very, very briefly there at the end, the monitoring assessment reports is a very small taste of a lot of the different, useful information you might find in there. We're running up against the runtime of the presentation here. So think about all the capabilities that we looked at today in terms of, the autonomous alarm routing with Win 911, the issue management capabilities with Peer, and the IS 18.2 monitoring and assessment reports with XL Reporter. All together with these three systems working together, I think SmartSites has sort of put together a very compelling sort of entry level, almost alarm management for the masses type solution, if you will. And it can be a very effective way to uh, you know, improve the performance of your alarm system. Again, in this era of remote work, of increasing digital complexity, and improving the alarm system, right, will improve the safety, efficiency, effectiveness of your plant. So I hope you all enjoyed today's presentation. Again, this is a recording, so if you do have any questions, please submit them to us by email. We'd love to hear from you. We'd be happy to answer any and all questions you might have. So please do reach out to us. And for more information, you can always find us online at our website, which is smartsites.com. Thanks again, everyone, for listening to today's presentation. Hope everyone has a great day and a great rest of the week.